Welcome to the DIY Honda Garage channel. The DTC P0102 indicates a low voltage condition detected in the mass airflow MAF sensor circuit. This sensor plays a vital role in measuring the amount of air entering the engine, which directly influences the air-fuel mixture essential for optimal combustion. A low voltage reading usually suggests an issue with the sensor itself or the wiring leading to it. Often, this could result from wiring defects or even a faulty sensor. The MAF sensor is located in the intake manifold upstream of the throttle body, where it accurately gauges airflow. When troubleshooting this code, ensure that general preliminary checks are considered before diving into specific diagnostics, as this will help in accurately identifying the fault. The MAF sensor, or mass airflow sensor, is a critical component in the vehicle's fuel management system, directly tied to the engine's performance. When it detects a low voltage condition, as indicated by DTC P0102, it suggests that there may be an electronic issue related to the sensor circuits, potentially leading to engine performance problems, such as misfires or stalling. Located in the intake manifold just before the throttle body, this sensor measures incoming air, allowing the powertrain control module, PCM, to adjust the fuel mixture for efficient combustion. This situation requires immediate attention to prevent further engine issues, and the verification of the issue must be completed first to confirm the failure's persistence. Several factors can lead to the appearance of DTC P0102. A primary cause is the MAF sensor outputting low voltage due to internal failure or degradation of the sensor itself, which could be attributed to age or contamination. Additionally, faulty or damaged wiring, often a short to ground or an open circuit, can interrupt the signal sent from the MAF sensor to the PCM. Lastly, failing components like the PCM, the main computer that manages the engine operation, can also cause erroneous data readings, leading to this trouble code. Proper diagnosis includes checking these components sequentially to isolate the failure accurately. When the P0102 code is triggered, several symptoms may manifest, significantly affecting vehicle performance. Drivers might experience reduced engine power and poor acceleration as the engine struggles to receive the correct air-fuel mixture owing to incorrect airflow measurement. An illuminated check engine light on the dashboard is typically the first warning signal and should prompt immediate diagnostic work. In some cases, engine stalling or increased fuel consumption can occur as the system attempts to compensate for erroneous readings. It's vital to remain observant of these symptoms to focus on resolving the underlying issue promptly. The first step in troubleshooting DTC P0102 involves verifying that the vehicle is in the on mode and allowing it to sit for 2 seconds. Following this, using the Honda Diagnostic System, HDS, inspect the parameters related to the MAF sensor specifically. Here, you are looking for the voltage reading, which should register at least 0.1 volts or higher under normal function. If the current condition indicates that the voltage is indeed below this threshold, it confirms a duplicated failure. Conversely, if the reading matches, the problem may be intermittent or due to loose connections, and requires further inspection to confirm circuit integrity and connection stability. For the second step, begin with the vehicle turned off to safely check the appropriate fuse. Specifically, you will inspect fuse number C30, which is a 10 kilowatt fuse located within the under-dash fuse relay box. An inspection of this fuse is critical because a blown fuse may indicate a short circuit within the IG1 ACG, IG1 main, or IG1 AFM lines, which are essential for powering the MAF sensor and IAT sensor. If the fuse is operational, it suggests the wiring is not shorted and you can proceed to the following diagnostic step. However, if the fuse is found to be blown, repair any shorts in the circuit and replace the fuse before further diagnosis. Step 3 requires the vehicle to be turned off, followed by the disconnection of the MAF sensor, IAT sensor, 5P connector. In this state, you will switch the vehicle back to on and prepare to measure voltage. With the connector disconnected, you will specifically measure the voltage between the first test point and body ground. This verification determines whether there is battery voltage available at the sensor circuit. If battery voltage is present, it affirms that the wiring is intact and not open. If no voltage exists, you will need to address this open circuit and repair the IG1 ACG or related wiring routed between the MAF, IAT sensor, and fuse C30. Step 4 involves taking resistance readings to further diagnose the MAF circuit integrity. Again, ensure the vehicle is off before checking for continuity. You'll measure the resistance between the specified test points on the MAF sensor 5P connector. Ideally, the resistance should fall between 190 and 210 kiloohms. This step is vital for evaluating the VGP line, as improper resistance readings may indicate a compromised circuit. If your readings fall within the acceptable range, proceed to the next step. Alternatively, significant deviations from this range may require repairs to the VGP circuit between the MAF sensor and related components. During the 5th step, you will first jump the SCS line using the HDS to allow for diagnostic functionality. With the SCS bypassed, disconnect the PCM connector B51P to assess continuity effectively. This involves checking between test points to ensure current flows correctly through all circuit paths. If continuity is present between the specified points, a short in the VGP wiring is indicated, typically between the PCM and the MAF IAT sensors, necessitating repairs. If continuity does not exist, you may rule out short issues on the VGP line and proceed to the next investigation step. The 6th step requires a continuity check amongst various connections with the vehicle off. Ensure both the MAF sensor, IAT sensor connector, and the PCM connector B51P are disconnected. This allows for a clear continuity measurement between the test points within the wiring. Success indicates that the VGP wiring is intact. Although if the circuit fails the continuity test, this points to an open wire condition that may require further investigation. Should the wiring be verified as intact, it may be necessary to update the PCM software or replace the PCM under certain conditions, particularly if software updates have not been applied previously. The 7th and final troubleshooting step involves substituting a known good MAF or IAT sensor, which is pivotal for determining the root cause of the DTC. Reconnect all connectors as part of the reassembly process before powering the vehicle back on. Use the HDS again to clear any remaining DTCs from the system, which will set the stage for functional verification. Start the engine and stabilize at 2000 RPM without load. During this phase, closely monitor for any reappearance of DTC P0102. If it does reappear, consider that the sensor itself is indeed faulty, requiring replacement. Conversely, if the code does not return, updating or replacing the PCM may be indicated. To ensure accurate repairs, a final check for DTCs is essential. Utilize the HDS to scan for any remaining codes, focusing specifically on the P0102 to confirm that it has been resolved. Successful verification means that the DTC is no longer present, indicating repairs were effective. If no additional issues occur during test driving, it validates that the MAF sensor circuit is functioning correctly. Always review engine performance and functionality during road tests to confirm that the issue has been adequately rectified. If any additional fault codes emerge, they must also be addressed accordingly. Preventive maintenance is crucial in reducing the likelihood of DTC P0102 occurring again. Regularly cleaning the MAF sensor can prevent contamination that leads to voltage discrepancies, thus maintaining sensor accuracy in measuring airflow. Periodically inspect the wiring connected to the MAF sensor to catch any wear, corrosion, or damage early on, which may cause shorts or opens. Additionally, owners should be proactive about updating the PCM software, as manufacturers frequently release updates that address known bugs or improve overall functionality. By adhering to these maintenance practices, you can not only prolong the lifespan of critical components, but also enhance overall vehicle performance and reliability. In conclusion, the appearance of DTC P0102 serves as an alert to potential issues within the MAF sensor circuit, crucial for optimal vehicle performance. Understanding the design, function, and common pitfalls associated with the MAF sensor is essential for effective troubleshooting. By following structured diagnostic steps, technicians can methodically isolate the fault and implement accurate repairs. Ensuring that quality parts and components are used during replacement enhances the longevity of any repairs conducted. Adopting preventive maintenance measures subsequently mitigates the risk of this code reappearing, thus maintaining the vehicle's reliability and operational efficiency. Please like and subscribe to the channel. See you next time.